Never heard of them before.
Yeah, cool. They're lots of fun. They're a great way for us to compare two different distributions. So this is the formula for a z-score, and we'll get straight into the question because that will reveal to you how we can compare two different distributions. So we have Rob received 83% on his maths test, and the maths test had a mean result of 74% and a standard deviation of 6%. He also received 62% on his English test, which had a mean result of 55 and a standard deviation of 3%. Which test did he do better on? Now you might look at that and just say, well, the maths, because he got 83, and the English he only got 62. But what we need to do is we need to compare his score relative to the distribution, okay? So his z-score for maths, so we'll call it Zm, is going to be his result, take away the mean, divided by the standard deviation. So what did we get? We got 83, take away 74, divided by 6. So what's that? 9 on top of 6, 3 on top of 2, 1.5. Okay, that's his z-score for maths. Let's calculate his z-score for English. Okay, so his result for English was 62%. The mean was 55. And the standard deviation was 3. So this gives us 7 on top of 3, which is 2.3 recurring. Okay, so here's what a z-score is, okay? It is a measure of how many standard deviations a result lies away from the mean. So what this means is for maths, here's the distribution for maths. He had a z-score of 1.5. Okay, so that means his result is 1.5 standard deviations above the mean. Okay, that was for maths. For English, his result is 2.3 standard deviations above the mean. All right, so it's much further along in the distribution, 2.3 standard deviations above the mean. So the question is, which one did he do better in relative to the class? English, right? Because it's much further along in the distribution. His result is much more at the higher end of that distribution. So to answer the question is, which test did he do better on? He did better on the English test relative to the class, based off of the z-scores that we've performed. So this is the formula for a z-score, and a z-score is a measure of how far a result is from the mean. It's a good way to compare lots of different distributions. Okay, then we have question 2, and we have some notation here just with the z distribution. The z distribution is normally distributed, so we write z, it's normal, with a mean of 0 and a standard deviation of 1. So that means the z distribution looks like this. Here's 0, and it has a standard deviation of 1, right? 2 going out there, 3 down this way, -1, -2, -3. Okay, remember, the z-score is a measure of how far a result lies from the mean. So if you're below the mean, your z-score is going to be negative, right? A z-score of -2, you're 2 standard deviations below the mean. Okay, so in this question we've got, given x is normally distributed with a mean and a standard deviation, we don't know what they are. We've got the z is normally distributed with a mean of 0 and a standard deviation of 1. Find a and b such that these probability statements are equal. Now all it means is a has to be 2 standard deviations below the z distribution. So if this is the z distribution and we're 2 standard deviations below it, a is -2. -2. And B has to be half a standard deviation above the mean. So half a standard deviation above the mean would take you to here. 0.5 standard deviations above the mean. So the value of B is 0.5. Okay. So that's it for z-scores. This is a short, sharp, shiny exercise. We should be able to get done in the first sort of half of the lesson, and then we can have some folio time.